So, as JP mentioned, this is organized into 3 hours. And so, kind of three back to back to back sessions. The reason why we're doing that is to try to manage it into chunks. And so, if for those of you who can't attend the entire time and maybe want to come back and catch the recording for an hour or two, you can plan accordingly. We're going to start each chunk on the hour and take a little break and have some exercises for you to do toward the end of each hour. The first hour is just going to be all about getting started with Tidycensus. Hour number 2 is going to be about wrangling census data with tidyverse tools. So that's going to start at 2 p.m. Central Time. And then at 3 p.m. Central Time, we're going to work on visualizing US Census data with a focus on some tools in ggplot2. All right, so let's kick off part 1. How do we get started with Tidycensus? What is it? What do you need to do to start bringing census data into your R environment? The first things first, that what I do want to touch on before we really get into the content is just flip over real quick to a couple things. So there's a companion GitHub repository here. For those of you who are familiar with Git and GitHub, this is going to be your portal to access the resources. You can search for me or use the links that JP provided on GitHub. You'll see I have a repository called UMISH Workshop. This is where all of the materials and the slides are going to be hosted for the workshop series. What you can see going on here is we have the code and we have a little terminal command that if you're familiar with Git, you can use to clone the repository to your computer. You can then navigate into that repository, specifically the census data in R folder, the code folder. You'll see this part1 code.r file. That's the one that has all of the code that you'll need to follow along today. As JP mentioned as well, if you are using R on your own machine, you will need to obtain a Census API key if you don't have one already. It's fairly straightforward to do that. Visit the link provided. You'll get an email from the Census Bureau to activate your key. Once it's activated, you'll be able to get started. If you're new to R, don't worry about Git or GitHub or even installing R on your computer necessarily right now. I've set up a cloud environment in RStudio Cloud that you can copy over yourself to a free temporary RStudio Cloud project. All you have to do is click this link, and that'll take you over to RStudio Cloud. And I'll show you what that looks like here. You'll see something like this, where you have all of the code available, and all you need is either if you have a GitHub account or a Gmail account, you can log right in, and you won't burn into a paid account with what we're doing today. All that code is sitting right there for you, and all of the R packages are pre-installed. This is the easiest way to get up and running. And then I have an API key provided here for you that you can use. So this is, one way that you can get up to speed if you're brand new to R and you're wanting to learn about this a little bit more, but you don't necessarily want to take the time to get everything installed and configured. A couple things about RStudio Cloud. This little button here, the workspace panes button, allows you to reorganize the different panes. And so you'll see here that there's a script editor. I'll be working in that in my own version of R. You'll see an R console down at the bottom here. I have my R console over on the right. That's how I like to organize my panes in RStudio. So if you want to replicate that, you can click this little window button here and choose console on right, and that'll move it over to the right-hand side. All right, with that in mind, let's go ahead and get moving. So typically, and for a long time, when I was first learning how to use and work with census data, I engaged in this type of workflow, grabbing data from the US Census Bureau. So my background is in population geography. That's where I do the bulk of my research. And so I'm working with data from the Census Bureau all the time. And this means spending many, many hours on the old American Fact Finder, which I'm sure many of you are very familiar with. And now that's transitioned over to the new interface at data.census.gov, which you can see up here in the upper left corner. So a traditional workflow might involve going to data.census.gov, finding a table from the census or the American Community Survey that you want, pulling that down as an Excel file, and then opening it up in your spreadsheet editor of choice and working with data from there. Now, this is a tried and true workflow and may work very, very well for a lot of applications, but it's not always the easiest to integrate into an automated workflow that uses, say, a programming language like R. You see how tables are often formatted. This is a stylized Excel spreadsheet here, but that doesn't necessarily align directly with, say, the types of data structures that are necessary to really get going with tidyverse or modern R-based tools. A potential resolution to that is an amazing resource that the Census Bureau has introduced and made available, which is the Census API. And that's linked here on the slide. But the Census API, if this is the first that you're hearing of it, is basically a data portal that allows developers to use a programming language or web queries to access census data resources. There are lots and lots of different APIs. And there are a lot of software resources that allow developers working in a variety of different programming languages to programmatically access those resources. One of the best ones in R is HANA Rex Census API package. If you're not using Census API, you should be. It accesses every single API provided by the Census Bureau. So if you want to plug into all of the different data resources that Census makes available, Census API lets you do that. ACS is an older package. It's been around for a while, but really innovated in this space, creating a programmatic R-based interface to interact with census data resources. If you prefer other programming languages, there are solutions for you. SenPy is my favorite, Levi Wolf's package over on the Python side for accessing and working with census data in Python. And then the City SDK package over in JavaScript is pretty great, allowing you to consume some of these data resources if you're coming more from the web development side of things. I'm coming to this, however, I'm talking about Tidycensus, which is the package that I created 4 years ago now to act as an R interface to a variety of different Census APIs. It doesn't have the breadth of Census API. It focuses on specific data sets that, to be frank, I commonly use in my work, but I've seen as kind of the most commonly requested data sets from the Census APIs. And so Tidycensus lets you get access to decennial census data, American Community Survey data, Population Estimates Program or PEP data, and then the public use microdata series APIs, which we'll cover more in a couple weeks. What Tidycensus does, it tries to be fairly opinionated about how it gets you data. It does a lot of data wrangling for you under the hood. It makes a request to the API, and then it formats that data specifically to help you do work within the Tidyverse and with Tidyverse tools. If requested, we'll talk about this more next week, you can download and merge census geometries to your, say, decennial census or American Community Survey data and give you back a simple features object. If none of that is really making sense at the moment, it's going to be very, very clear to you next week. But basically what that means is, for those of you who come from a GIS background, you might be familiar with going out and finding census tigerline shape files and then opening it up in ArcGIS and then formatting your CSV files in Excel and then bringing that into ArcGIS and then aligning your GeoID column and doing a join. Tidycensus does all of that for you, and we'll show you how to do that next week. Tidycensus also includes tools for handling margin of error. We'll talk about that a little bit more in hour 2, and working with survey weights in the PUMS data. And one of the main reasons that I started writing R packages, truthfully, is because I could never remember FIPS codes for states and counties. I always had to look them up. And so I thought, well, I might as well write a little code that allows me to just type in the name of the state or the county and never have to remember that again. And so that's something that Tidycensus does provide. So how did I get to this point? What is the trajectory of Tidycensus? Where does it come from? So it's kind of an interesting path that I personally had gone down with respect to R. I didn't actually learn to code until after I completed my PhD. I did SPSS all the way through in my PhD program, did all the data analysis in SPSS for my doctoral dissertation. And it really was my first job, non academic job after grad school, where I started to realize that I was doing common tasks over and over again. And I would write it down in a notebook to try to remember what I did, but I couldn't always remember exactly the steps if I got something wrong. And so I got a suggestion from a colleague. Well, have you ever considered scripting this and taking it down? And I didn't really know much about it. I didn't think of myself as a developer, but eventually I started getting a little bit into Python and eventually R, and started putting together scripts that completed a lot of very common workflows for me. For example, if I'm working with census data all of the time, I'm requesting oftentimes the same 12 to 15 tables from the American Community Survey for a variety of different geographies. And I'm having to go through the same steps over and over. And so when basically, I think this is an adage from David Robinson, who's prominent in the art community. At least I've heard him say it. If you have written the same script 3 times, write a function for it. If you've written the same function 3 times, write a package. And ultimately, that's the trajectory I went down. I was doing the same thing over and over, downloading the census data, joining it to spatial data, transforming the tidy format. And then I started to accumulate all these functions that did that sort of thing. And eventually I started dabbling a little bit into R package development. You could see a very early implementation, ACS 14 Lite, which was sort of a very idiosyncratic approach to working with data from the 2010 to 2014 5-year ACS. But those were the roots of Tidycensus several years ago. So eventually, I cracked open Hadley Wickham's R packages book, taught myself how to, well, by reading the book, taught myself how to write a package, and eventually open source the package in 2017. And Tidycensus has been downloaded hundreds of thousands of times. It's been fantastic to see the uptake within the community, and it has a number of different contributors now, which has been wonderful. In particular, Matt Harmon, it has become a co-author of the package as of last year, and he's responsible for writing a lot of the microdata code. So when we get to the 25th, a lot of the functionality that makes it much, much easier to work with microdata from the API, that's Matt's brainchild. So he's made some fantastic contributions to the package. So as far as getting set up, if you have the RStudio Cloud environment going, these packages are already installed. You don't need to worry about installing packages. If you're a longtime R user, you probably already have these packages installed. If you have R set up on your own computer, but you're relatively new to R, go ahead and run this command that you see here on the screen, and that will install the packages that you need for today, save for the very, very last examples, which we'll set up at the end. Something that you'll see as we follow along here, and I'm going to flip back and forth between our environment and the slides. What you'll see here is that all of this code from the slides is also in this part1 code.r script. And so what you can see here is that I have a line of code to install those packages. I'm not going to run that because I have already installed those packages. But if you need to do that, I would recommend doing that. If you're having trouble getting those packages installed, this can particularly be an issue sometimes on Mac, especially if you're using Linux. There's some system dependencies that are necessary, especially to get spatial libraries on which Tidycensus depends up and running. If you're having problems there, I would say just hop over to RStudio Cloud, run that there, and then file an issue over in the Michigan Workshop repository where we could potentially get that debugged. The second step to get started, and we've mentioned this a couple of times already, but you'll need a Census API key. You can technically access the Census API without a key. If you go to the Census website, you can type in a query and it'll work without a key. but it's heavily rate limited if you don't have a key. And so Tidycensus requires a key to work. To get your key to work, once you've acquired it, you're going to use the Census API key function to set your key as an environment variable. An environment variable, basically what that means is it's an R variable that is accessible to your global environment. And the Census API key function, which includes some fantastic contributions as well from Chris Eberwein, who allowed for the installation of this key in your environment file. If you replace this code here, your key goes here with your API key, and you run it with install equals true, it will write out your API key and it will save it for you. And so every time you start up R from there on out, it'll be saved for you, and you don't have to worry about remembering your key really ever again. And then you don't have to hard code it in any of your scripts, which is also a good thing. So go ahead and get that set up. If you're installing the key, it might prompt you to restart R. And so restart R if you need to, but also you don't have to install the key. If you just run this one time, it will set it for your current R session, and you'll be good to go for today. All right, so that's the setup, that's the background. Let's spend a little bit of time getting to know Tidycensus. So there are two main functions in Tidycensus that you are going to encounter and use the most. And a little bit of background for those of you who are brand new to R. Basically, if you're here, you have some interest in R, maybe some experience in it. R is one of the most popular software environments for statistical computing, but not just that. It can do really just about anything that you can put your mind to. And when you're working with R, there are going to be a variety of different building blocks that we're interested in. And so this workshop isn't intended as a broad introduction to R, but if you are new to R, there are a couple different concepts that will be important for you to understand. A couple object types in R that you'll want to know about are variables and functions. Those are core components of programming. You know, when I teach Programming 101 in my data analysis class at TCU, it's one of the first things that we cover. And you can think of this, I'm going to go back to my R environment. What we have here that's highlighted is an object named pop10. That is a reference to some other quantity of interest. It's going to store something. In this case, it's going to store data. The arrow operator here is an assignment operator, which means, and you can read this as, assign the result of whatever this code is to this object named pop10. So pop10 is going to store whatever we get back by running this code. Get decennial is a function. You can think of a function as a method or routine or a command that does all sorts of stuff for you under the hood, runs a bunch of other R code under the hood, but allows you to express all that R code in a very minimal way with what are called arguments. And so inside of parentheses, we call the function with arguments. This is about the simplest way that we can use Tidycensus. We see here, we're creating a new object called pop10, and we're using the get decennial function with two arguments, geography equals state and variables equals P001001, which is for total population. Get decennial defaults to the 2010 decennial census. To run the code in RStudio in your script, you can highlight that code and click the run button. You'll notice that there's also a Control-Enter keyboard shortcut that you can use if you'd prefer that. When I run that code, you'll notice that you get a little error message that says could not find function. And this is going to be important, especially if you're new to R. Notice the code here that says library tidycensus. When we run that library function, what that does is it brings in all of the functions from Tidycensus into your R environment so you can use them. If I run library tidycensus and now try again, Now my code runs correctly. So you'll notice I get a little message here that says getting data from the 2010 decennial census using census summary file 1. What I can do now is take a peek at my data. And so I'm going to go ahead and print out this pop10 object and click run. We notice what we get back here. It returns something called a tibble. And a tibble is sort of a stylized version from the tidyverse of a regular R data frame, which you can think of as a rectangular data object with rows and columns. By default in Tidycensus, you get back from get decennial 4 columns, GOID, name, variable, and value. And then each row here represents a state. So the rows represent a value, a variable state combination. And so what we have here for total population in 2010 of Alabama is 4,779,000, thereabouts. Another functionality of RStudio, and I'm using the RStudio environment here, which if you're in RStudio Cloud, you're using that as well. So if you're using RStudio, if you look at the environment tab, which for me is down here on the lower left, you'll see that all of my objects that I've loaded in my environment are going to be found here. If I click this little data grid button, I will pop out the data viewer, which is an interactive data viewer that allows me to browse my data. So those are some of the basic kind of pieces that we can work with inside of R and RStudio to work with census data. But notice what happened. All we needed to do was say, I want from the decennial census population data by state. And I get it back within a half a second. Jumping back here to the slides, you'll also commonly be working with in Tidycensus the American Community Survey. So the American Community Survey is a companion to, but distinct from the decennial census. It's an annual survey of around 10 million households, so it'll cover maybe between 9 and 10 million people a year. And it asks more detailed questions than the decennial census. So whereas the decennial census, for those of you who filled out your census form back in 2020, you were asked about race, ethnicity, age, sex, and really not a whole lot more than that. The American Community Survey is a longer survey, but it targets only a smaller sampling of households. And so that's where you'll get information on income, education, occupation, language, and a lot of other demographic statistics that are not found in the decennial census. The get ACS function is going to be your workhorse for grabbing data from the American Community Survey. This function defaults to the 2015 to 2019 5-year ACS. There are 2 active ACS data sets you can get. The 1-year ACS, which comes out every year and focuses on a specific year, covers populations, geographies of population 65,000 and greater. The 5-year ACS, which is sort of averaged over a 5-year period to deal with sampling size issues, allows you to get geographies all the way down to the census block group, which we'll explain a little bit more in a moment. So the code you see here on the screen, what that is getting is at the state level from the most recent 5-year ACS, 2015 to 2019, data on median household income. So the variable code here, B19013_001, that gets you median household income. That's the code that corresponds to that. And so if we go back to R, I can fetch that data. I get another little message here that says I'm getting data from the 2015 to 2019 5-year ACS. I can print out the result. And here's what I see. You'll notice that the data that we get back from get ACS looks a little bit different from the data we get back from get decennial. As the decennial census is designed to be a complete enumeration of US population, its values that it reports back are not characterized by sampling error or margin of error. So we don't get that information back. The ACS, being based on a sample, is characterized by margin of error. And so Tidycensus by default always gives you back the estimate. So in this case, your estimate represents the estimated median household income by state. And then that's found in the estimate column. And then the MOE column represents the margin of error around that estimate. Margins of error in the ACS by default are reported at a 90% confidence level. So you can read this roughly as in Alaska, the median household income is $77,640 plus or minus about $1,000. And we're 90% sure that the true value lies somewhere in that range. That's roughly how you can interpret that. And so this was a design decision that I made early on when writing Tidycensus, as you know, ACS estimates are often treated as counts. And while they are an estimate potentially of count data, they don't represent precise numbers and really shouldn't be treated as such. And we'll talk a little bit more about how to handle that in hour 2 and also in hour 3. So as mentioned, you can get data from the 5-year American Community Survey. You can also get data from the 1-year American Community Survey. And so the argument survey equals ACS1 allows you to grab data specifically from the 1-year ACS. Remember that the 1-year ACS only gives you data back for geographies of population 65,000 and greater. And so if you're doing county level analysis in your state, you're only going to get data back for the largest counties. So that's something to be aware of. You'll need the 5-year ACS to get everything. That said, if you're doing, say, state level analysis, or if you're analyzing metro areas that are very, very large, the 1-year ACS may be the way to go. And so in this particular case, we're grabbing the same data, median household income, but from the 1-year American Community Survey instead of the 5-year. And so I'm going to go back to R and I'm going to run that code. Notice here that the structure is the same, but look at the margins of error around those estimates. You'll notice that Alabama's estimate has gone up slightly. Alaska's estimate has gone down. Arizona's estimate has gone up. So we're getting more recent data here. So if you need the most recent data, this might be a better option for you to go for the 1-year ACS. But also notice that the margins of error are larger. For example, the margin of error around the estimate from the 5-year ACS in Alaska was only around 1,000, but from the 1-year ACS, it's about 2,700. So while we're getting more recency with respect to our data, we're also adding uncertainty in those estimates. So that's just something to be aware of. Data in the American Community Survey and also in the decennial census are organized into tables. And tables represent groupings of common variables. You know, for example, you might be interested in grabbing data on age and the age and sex structure of the population. This is a pretty commonly used table for a variety of different applications, but you don't necessarily want to type in every single variable code to get that. That's where the table argument comes in. We can specify here using getACS that I want all of the variables that start with B01001, which covers the age and sex structure of the US population. I can jump back over to R and I can run the code that generates that. And you'll notice what I get back here. I have a bunch of different Alabamas. By default, Tidycensus returns data in long form. I'll talk more about what that means in just a second, but we have all of these different values stacked on top of each other. We've got Alabama. This first value here is going to be the total population. And then we have all of these different variables that have the B01001 prefix. This one here is the total male population, and then it starts breaking it down into different age groups. You might be asking at this stage, well, how do I know what these different variable codes mean? We'll talk about that more in just a little bit. Another thing that Tidycensus allows you to do, which is because the Census API allows you to do it, is subset your data down by geography. And so we're going to talk a little bit more about this, how to understand geography and how to understand variables. Because as you've seen, there are a couple default arguments in get decennial and get ACS, geography and variables. That seems simple enough on the surface, but when you really start to dig in, you'll sometimes think, well, how do I know what the geography is? How do I know how to format that geography? How do I even know what geographies are available? How do I know what these different variable codes mean? I have Kyle here telling me that this ACS code means median household income, but how do I find that out for myself? So looking here at US Census geography, the US Census Bureau tabulates data at a variety of different geographies. The core census hierarchy kind of goes down the middle here, which means that these geographies nest within one another. We'll talk more about what that means next week. So you have census blocks, block groups that go up to counties and all the way up to the whole US. Then you have all of these other geographies in which you can grab data. Tidycensus gives you access to most of these geographies. And if you go to the Tidycensus documentation, which is linked here on this slide, or if you go to walker-data.com/tidycensus, you can find how to format all of these different geographies and in which data sets you can get them. Once you've grabbed this information, you can specify using state and county arguments how to subset down your data. For example, let's say I want to grab data on median household income again by county, but I only want it for the state of Wisconsin. I can specify geography equals county and state equals Wisconsin. And if I go back to R, we can take a look at that. You'll notice I get a message that we're translating to FIPS code 55 for Wisconsin. And here we have all the counties in Wisconsin with their estimates and margins of error. Beyond that, I can subset further. Let's say I want to grab census tract data. I can specify here geography equals tract, and then say I want to grab data specifically for Dane County. So census tracts, if you're not familiar, they are loosely analogous to neighborhoods. So on average, they have about 4,000 people, but in practice, they can range between 1,000 and maybe 12,000 people. If I run this code here saying I want tract level data for median household income for all of the census tracts in Dane County, Wisconsin, I can run that code and take a peek. And here I go. Now I have at the census tract level for all 107 census tracts in Dane County, which is Madison, Wisconsin, for those of you who aren't familiar, I have median household income information. So that's how you handle geography. But how do you handle variables? This is a very common question. And this is a hard thing to deal with, to be honest, because there are tens of thousands of variables in the American Community Survey. How can you possibly remember the codes for each and every one? Well, fortunately, you don't have to do that. And we've written in Tidycensus some functionality to try to make it easier for you to look up variables. This is not the only way that you need to look up variables. I strongly, strongly recommend Census Reporter. It's really my favorite resource. I use it all the time to look up ACS variables, but we do have functionality in Tidycensus to help you out with that too. For example, what we see here is the use of the load variables function. If I specify the load variables function with a data year, or in this case, the end year of the 5-year sample, and then a data set, which here is ACS 5, I can pull down all of the variables from the ACS, and then I can use the interactive viewer in RStudio to browse. So running this code, I'm going to go ahead and run that through. It'll take a couple moments because it's pulling down a JSON file from the census website, translating that into an R object for us. And it'll just take a few moments to pull that down, but when it does, you'll get a browsable object that you can go ahead and take a look at. And so here we have all those 27,000 variables in the ACS, but in an interactive browser. You'll see here all of those variables in that sex by age table. Now I can see what the correspondence is. B01001_003, that's males under age 5. I can also use this little filter button to filter these different columns and look for keywords, or I can use this little search button up here, this search dialog, to look for, wherever it shows up in any of the columns. So let's say I'm interested in education. I've now filtered this down to 988 variables out of 27,000. So these are all the variables that cover educational attainment. I'm still going to need to browse around a little bit. That's still going to take a little bit of time, but at least this narrows it down for me. So I would strongly recommend using that functionality. A couple other things of note before we move into the first break. We're going to be talking a little bit about data structure in Tidycensus. And as I mentioned before, I designed Tidycensus to be sort of reasonably opinionated with respect to the structure of data that it gets back. And this is something that we'll return to at the beginning of the second section of this workshop. I named Tidycensus as such, Tidycensus, because my goal all along was to build out an interface to the Census API that fit well within the tidyverse workflows that I used in my work. The tidyverse we'll talk a little bit more about in hour 2, but the tidyverse is a very popular paradigm for data analysis and visualization in R. It is not used by everyone, but it's very, very popular, and it happens to be what I use. And so I designed Tidycensus to get data back in a way that integrates directly with those tools. But this might not be exactly the format that you are the most comfortable with. And so I have some other options to help you out and return data in other formats if need be. So I mentioned this before, but when we're grabbing data here by state or specifically by table, we get what's called long form or tidy data. The tidy data structure that I use in Tidycensus, as I interpret it, is where each row represents a unit variable combination. So each row is not a single state, it's not a single variable, but rather it's the combination of the variable and the state. Everything is then organized into, we've got an estimate and a margin of error column for each of those different brackets. This table here is household income breakdown. So we have here the first variable is B19001,001. That's the total households for which income is determined. And then we have a bunch of other income brackets here with their associated margins of error. And so we can use this sort of structure, and I'll show you why I use it in Tidycensus in just a moment. However, and I'll sometimes hear feedback about this, people aren't always the most comfortable with that particular kind of structure if they're coming from a different data analysis paradigm. Commonly, and I came from this paradigm as well, if you're coming from a GIS background or a spreadsheet background, you might be more comfortable working with wide form data, where you have the variables spread across the columns. If you specify the argument output equals wide, you get this back by default. And I'm going to jump back over to R and run this for you. And we can take a look and see what this looks like. So basically, what we're doing here is we're fetching the data and then formatting it in wide form. And so instead of the 5-column output with the GeoID, which is the census ID code, the name, the variable, and then the estimate and the margin of error, we get a bunch of estimates and a bunch of margins of errors that are attached themselves to the different variable IDs. And so if you're working in a geographic information system sense, an ArcGIS type workflow, this might be something that's a little bit more comfortable, because in this particular example, there is only one row per state. So we have 52 rows. So that's the US states plus Puerto Rico and DC. And we see here that all of those data values are spread across the columns. Notice that we still retain the estimate and the margin of error. You never have to specify estimate or margin of error when requesting data from Tidycensus because it always gives you both back by default. That is a design decision that we've made. And so this might be more comfortable for you. You've got a lot more columns, but you have fewer rows in this type of data set. The last little piece that I want to show you is another way to try to keep track of some of the variables that you're working with. Those codes that represent different variables in the American Community Survey or the decennial census, they can be tough to remember, even if you've been working with them for a very long time. And so a feature that was requested shortly after I first started developing the package that I like very much is the ability to use a named vector to request variables. And it then gives you your variables back and replaces the variable name with the name that you've specified. So for those of you who are unfamiliar or new to R, the C function is one of the most commonly used functions that you'll come across. It allows you to create a vector, and a vector you can think of as an object that has multiple entities stored inside of it. And so in this particular case, if I specify for the variables, give me back for counties in Georgia, this particular census ID, ACS ID, which is for household income, and then call it Med Inc. because I know what that means. And for this particular variable, which is median age, call it Med Age. If you run that code through and then take a look at the output, you'll notice that the ACS variable ID gets replaced with what you put in. So I could have been even more explicit about this if I wanted to. Median income, median age, and I can rerun that, and I get back exactly what I asked for. So this is a little trick that you can use, especially if you're uncomfortable with working with the ACS variable codes, which honestly, I completely understand. I've sometimes had questions asked, well, would it ever be possible for me to just type in variables equals median income and get back median income? I understand the desire to do that. The problem is there's so many different variables in the ACS that get slightly replicated and refer to different subsets of one another that I've resisted that incorporating that feature. But this is one way that you can kind of do that as a workaround. Find those variables using load variables like I showed you, and then, create a catalog where you know which variables that you want to use in your project, and then use a named vector to overwrite the name of the ACS or decennial census variable, and you'll have really a more descriptive output data set. All right. That takes us to the end of part one. So what I have baked in here is maybe around a 10 to 15-minute break or so for each component. And so perhaps what we can do, Bill, JP, is let's take the next 10 minutes for participants to fiddle around and play around with Tidycensus themselves and try it out. And when we come back right at 2, let's go ahead and do a little bit of Q&A from part 1 before diving into part 2. So let's take a little bit of a break here, but I do have some exercises for you to work on if you want to practice this a little bit. So the first one is take a look at the Tidycensus documentation and grab data on median age for a geography we haven't yet used. So maybe you could look at census tracts in the county where you live, or maybe just median age by state and see how that compares. And the second exercise is to use that load variables function to browse and find a variable of interest to you, and then use get ACS to grab data from the most recent ACS for counties in the state where you live for that variable. So there are a couple practice exercises for you. Let's go ahead and break, and we'll reconvene around 2 o'clock, do a little Q&A, and then delve into the second hour.